Good morning. Myself, Dr. M. Ravi, Professor, Mechatronics Department, K.S.Rangasamy College of Technology, Tirunelveli. Today, we are going to see about analog devices and digital circuit, introduction to semiconductors. Classification of material based on energy band theory. The based on width of forbidden gap material and are broadly classified as conductor, insulator, and semiconductor. The energy band, based on the energy band, the forbidden energy band is very high. It means it is the insulators. The conductor, the valence band, and the conduction band between two, there is no gap. In semiconductor, there is a small gap between the valence band and the conduction band. Insulators are those substances which do not allow the electric current to pass through them. Example, rubber, glass, and wood. These are the insulating materials. There is a valence band is very high. In terms of energy band, insulator are those substances which forbidden gap is very high. Thus, the valence and the conduction bands are widely separate. Therefore, insulator do not conduct electricity even with the applications of large electric field or by heating or very high temperatures. Next, conductors. Conductors are those substances which allow electric current to pass them. Example, copper, aluminum, salt solutions. These are the examples of conductors. These substances conduct the electricity. In terms of energy band, conductor are those substances in which there are no forbidden gap. In insulator, there is a large forbidden gap. In terms of conductor, no forbidden and overlap. We already see in the diagram. Its forbidden gap is high. It is an insulator, and there is a no forbidden gap. It is an overlap between conduction band and overlapping band. And a semiconductor, it is a conduction band and a valence band is a small. Next, semiconductors. Semiconductors are those substances whose conductivity lies between the conductors and insulators. For example, silicon. Germanium. This kind of substance, there is a valence band and a conduction band is a very forbidden gap is very narrow. It is not overlap. In terms of thus the valence band and the conduction bands are moderately separate. In semiconductor, the valence band is partially filled. The conduction bands also partially filled, and the energy gap between the conduction and the valence band is narrow. Classification of the semiconductor. The semiconductors are classified into two types: intrinsic semiconductor and extrinsic semiconductors. The intrinsic semiconductor, the semiconductor is an example or pure form of pure form is known as intrinsic semiconductor. Example, silicon and germanium. Both silicon and germanium having 4 valence band. Each atom form into covalent band or electron pair bonds with electrons and the neighboring atoms. The structure is shown below. The structure clearly shows us silicon and germanium, the valence and the conduction bands. The crystalline structure of silicon and aluminum. This is the crystalline mixture of silicon and aluminum. At a low temperature, all the valence the free electrons are available for the conductance. The semiconductor therefore have as an insulator absolute at zero temperature or room temperature, free from electrons, valence bands, and holes. The intrinsic semiconductor at room temperature, some of the valence band of electron gain through the thermal energy break up of the covalent bands. The breaking up of a set of electrons free and are available for conduction. When the electron from the covalent band and become free electron, vacancy is created, such as vacancy called as hole. It carries a positive charges and under the influence of electric field in the direction of electric field applied. The number of holes to equal to the number of electrons, since the holes is nothing but the absence of electrons. When an impurity is added to the intrinsic semiconductor, it is a conductive charge. The process of adding and impure extrinsic semiconductor is added. Extrinsic semiconductors are further classified as N-type and P-type. N-type semiconductor shows that energy band when the small current prevent the impurities added to pure semiconductor is called as N-type semiconductor. The additional prevented impurity provide a large number of free electrons in a semiconductor crystal. The typical example for prevent impurities are autonomy and phosphorus. Such impurities produces type of semiconductor known as donor impurities because of that donate or provide free electron from the semiconductor crystals. Thank you for watching. Keep learning and growing. Thank you.